machines, and now they have atomic machines, with chemicals. That's how we explain life. So then I changed to cognitive sciences, physical sciences, life sciences, cognitive sciences, okay, psychology, okay. And well, then I had to graduate. So I graduated and already had started improvisational theater, which seemed like the best psychology around. So then I applied to UCLA and Northwestern, and they both said, "Hey, we'll give you full fellowship. Come here." Okay, yeah. And then I got Donald Campbell for a mentor, and he was head of the American Psychological Association, and he said, "Yeah, you figured it out." He said, "This is just a career track. You're not going to be able to do anything creative you want to do until you're at least 40 or 45 years old. You're going to have to work for other people and all this kind of stuff." And he said, if you got any manly qualities, he said something else. If you got any manly qualities, you'll get out and go to Asia. Check it out. If I was a young man, I would do it. And so then I kind of I left, and then I got a black belt in Okinawan karate in California, and studied with Gunnar Lind. He was a Swedish cabinet maker. These guys had influenced me. And finally, I got Prabhupada's book. I started reading it, and then the devotee tricked me into buying it. Okay, it was a big Krishna book, but I was very seriously reading it, and there's so many strange things. And I was associating with Prabhupada. I didn't know it, and I was in the book and stuff, and so I had all these strange experiences, deep experiences. And then I met, and then went to the temple, and then gradually got, involved in more and whatever, and finally the Bhaktivedanta Institute, everything else, and so on. But yeah, when I was born in 1948, so after World War II, science was king. Science gave us radar, science gave us atomic bombs, science gave us medical advances, science gave us, in manufacturing techniques, They stopped manufacturing automobiles when the war started. Everything stopped. They were turning out one complete B-22 every 15 minutes. Every 15 minutes, a new complete bomber was coming off like that. The Japanese and the Germans could not. They just couldn't accept it. They had all the evidence. The top guys, they just. We can't shoot them down as fast as they're producing it. And then they also did the same thing with the training to replace the pilots and stuff. So anyway, that's why at that time, whatever science can do, science must be allowed to do. So I got involved with science, but I didn't like it. It's just very, actually the scientific methodology is what the Bhagavad Gita calls knowledge in the mode of ignorance. To know a tremendous amount about one thing, that's because it's called knowledge in the mode of ignorance. If you get a PhD in science, you've got to come down to knowing one problem so precisely that, practically speaking, there's 4 or 5 people on the face of the earth who can really understand what you're talking about. Okay, then you get the PhD.
And if one gets it wrong, the whole world gets it wrong. If one does a PhD, gets it wrong, because everybody's quoting that has an authority, but he got it wrong.
Everybody gets it wrong.
So sociologist Marshall McLuhan, he said an expert is somebody who never makes the smallest mistake as he proceeds towards the grand illusion. That's exactly what you're saying. And that's and just totally lost. Sariputta had the scientific mentality, so he would argue with the doorkeeper just as readily as he argued with a Nobel laureate. So Swarup Damodar would have to come along and say, Sariputta, come, this man is a nice man, I know, but come over here and talk with this person. But that was it. Swarup Damodar couldn't keep up with him when it came down to arguing details and stuff. These big scientists, they said, Thompson, I don't agree with you, but you can play a game of hardball. They appreciated. He was Nobel laureates and stuff. He was good. Yes, Sariputta.
What about quantum physics? No, many people speak about quantum physics.
Quantum mechanics, yeah.
Quantum mechanics.
Yeah.
In Spanish they say física cuántica. Quantum.
Okay, you have your atom with a nucleus made of protons and neutrons, okay? And electrons are going around. That's one way of describing it. Not actually accurate, but why not, okay? Ooh, okay. And some are, to make it simple, spinning at this speed, so they're here. And some of the electrons are spinning faster, so they're here. So maybe you have 3 different levels of shells, okay. But they're distinct, each shell, right? So one idea is that if you pump energy into it, you can gradually move the thing from one state to the other. This is in the very beginning. But Einstein said no, that there are quantum leaps. It's going to be here or here or here or here, right? And so they did the experiments and they found out, it's either here or it's here. So quantum mechanics refers to the original thing about how the mechanics of the thing is based upon these quantified jumps. It's not gradual. No, you're going to be here or here. Yeah, it's going to be in this orbit or this orbit. There's nothing in between. Yeah. So it doesn't. But then they expanded that into so many, so many other things. But it comes from that original question.
Okay, because I hear that through quantum physics explains that a particle can go through 2 places at the same time. Somebody told me that.
No. It doesn't. It doesn't explain that, but the way it does explain it, creates that possibility. Yeah. It's called Schrodinger's cat. Schrodinger's cat. Schrodinger, a big physicist, had a cat. So if the particle goes through one side, Schrodinger's cat dies. If it goes to the other side, Schrodinger's cat lives. Okay, that's the main way they described it. But the way the mathematics describe all this stuff, they're only going to tell you that both things are possible. Schrodinger's cat is both dead and alive. Yeah. It's, they have the orbit of the planets, right? They're going around the sun, right? But they're not going around the sun. They're going around ellipses, like that, okay? You cannot describe this using arithmetic or geometry. They just won't do it, right? Or even analytical geometry. You can't do it, So Newton invented calculus along with Leibniz, okay? So what calculus does, it gives you estimate, right, of the orbit, that has an infinitesimal error, an infinitely small error. It doesn't give you the answer, but it gives you an answer that is infinitesimally wrong. This is what we're talking about, how they get into these unlimited speculations. It gets even worse than that, but that's what calculus does. It doesn't give you the answer, but it gives you an answer that could be infinitesimally wrong. Well, who cares? Practically speaking, the fundamental law of calculus is, given any function f of x and any change in f of x, you can always find a change in x that will fall within that. So no matter how small I make it, I can keep making it smaller, right, to fit inside that. Yeah. And so because of this, you can then generate a system which will go down as small as you want, and actually some of the things actually converge, and so it really looks like it's the truth, but it's not. Sadhguru told me, you don't need anything more complicated than calculus to build a 747. Yeah. But they have other systems of mathematics that are just like, it's strange. I mean, Einstein, to describe the motion of these particles, he had to use a 4-dimensional normed Riemann space. I was talking with Sadhguru one time, and I asked him, we've been talking, letters and the phone. I met him finally. He said, "Oh, that's what you want to know." So he just went right into it, and I said, "Can you talk just a little bit slower?" And then I could understand what he was saying. But otherwise, I couldn't. My mind could not form the concepts fast enough to keep up with him. but that's a little bit slower than, yeah. We had a competition. I think in psychology, I was able to outgun him. Yeah.
How do you know?
Pythagoras' theorem. The sum of the sides of a square triangle. A triangle, is square with a line across. A right triangle in English. Yeah. The square of the square of the hypotenuse is equal to the sum of the square of the sides. Okay. That's only true in some spaces. Other spaces, it's not true. So that if it's true, it's called a normed space. Yeah. And so Riemann came up with this other kind of space. So what Einstein was using was a four-dimensional normed Riemann space. And then he could describe the motion of these particles when they were smashing atoms. Otherwise, they couldn't do it. And so then, okay, oh wow, we got it now. Well, now we can, just do all kinds of stuff. Okay, so we're running along the atoms and stuff, and hey, wait a second. If we break whatever it is, uranium, right? Uranium-238. If we smash it, it'll produce boron and something else. And it'll produce a lot of extra energy, right? So just by the theoretical thing, they discovered, atomic energy, right? And then they actually tried it out and they made the atomic bomb, So it's very famous because they just went from pure theory, to something unbelievable. He discovered it. But he had to have, very special mathematics. A spiral, right? Yeah, spiral. It's almost impossible. It was very difficult to describe in regular square geometry, but in polar geometry it's simple. But try and describe a square in polar geometry. Yes. Yeah. So, yeah. Okay. But then you come up with again hyperbolic space and normed Riemann spaces and stuff. Yeah. And it does. People say that none of this stuff exists. The Christians say this, and none of this stuff exists, but God sees these people want to do this, so he starts making space more and more complicated. So they, like children, you give children all this kind of stuff so they can go and play, hide stuff in the sand and stuff, hide pennies in the sand when they're not looking and stuff, and they start.
So, it's like outer space.
Very nice point. How Krishna is
satisfying.
Outer space. Very nice point. How Krishna is satisfying.
Manifest.
Yeah.
The more we look, the more it will manifest.
Yeah. Just for
to keep expanding.
Keep the children occupied. They're digging a hole. You toss a penny in, and they're gone for the rest of the day digging the hole. Yeah.
Fancy storytelling.
Yeah. Well, also another time. Scientists are trying to describe how life was created, And one theologian was thinking, he said, all of the qualities that you're starting to attribute to matter, all the qualities that we attribute to God. So eventually, matter has all the qualities of God. So they're very interesting. But the thing is, their real motivation is, sex and power. So forget everything else. As long as we can make atom bombs and birth control pills, we'll
enjoy it without getting in trouble.
Yeah, we'll keep funding you. Yeah. But the thing is, it's not making people happy.
No.
Yeah.
And then they take this thing and that thing to try, and it's just.
So the budget for theoretical physics has dropped down to the same level as the budget for the Department of Theology at Oxford University. Yeah, like I said, they're producing nothing new. So theoretical physics is
just
string theory.
Just eating the money. No.
Yeah. So the doubt.
Now will be artificial birth and also immersion chemicals, pills, substances for artificial feelings.
Yeah.
And artificial womb.
Yeah. Yes.
That's next.
Hasn't ever worked. In vitro. Yeah, taking a baby out of the womb and putting it back into a womb, they've done that, but so what? It's Even if they talk about because you meet a lot of scientists are in between and stuff, and so you start talking with them, and they start giving you the information that if you clone, you can clone fruit flies. Fruit flies are their favorite subjects. Almost all genetics is based upon the study of fruit flies. because they can just produce them. So you can get blue eyes, red eyes, black eyes, 5 legs, and stuff, and do all these experiments, and there's no problem. So you can clone all these simple dudes and stuff, and they grow. But as soon as you start with sheep and stuff like this, the embryo grows for some time, it expands, and then it deforms and dies. So basically, it's like if you're building real simple houses, then a lot of people are ready to move in and take charge and live there. Building a mansion, okay, but then there's nobody who's willing to pay to live in the place. After a while, the plumbers stop working, and the grass starts going, and the whole place falls apart. So to have the karma to be qualified to take up the body of a sheep, not so rare. Fruit flies, there are plenty of people who have got that karma. And so it matches our same thing. They're discovering, you can clone all this stuff, but hey, honestly speaking, it doesn't work with higher beings and stuff.
So they are not ready.
No, it's a whole thing. Because all the thing is propaganda, this and that, and Sri Damodar. Because when he's talking to these people, he establishes a friendship and a trust and stuff, and then they can start talking, about things that, not so popular to hear and stuff in the profession and so on. Yeah, they were saying, one interview was like, I forget the guy's name, but he says we're still, decades away from that, honestly, from that, doing that kind of thing. So the guy, they asked this guy, Dawkins, do you know of any mutation which actually produced a superior being? And he's big. I mean, the other guy, the theologian said, he respects the guy, a genius, But that's the kind of thing, what happens if he actually changes. One of the biggest guys, Benjamin Few, Oxford, was a big atheist, but he became a Paramatma body, that and stuff. There is somebody behind all these things. And when that happened, oh God, it was just, the atheists were just like, miserable. It was like, oh my God, this guy. It's like Shankaracharya, changing his position, or Shankar, again, like what was Prabodhana, what was his name? He surrendered to Lord Chaitanya in Varanasi, Prakashananda Saraswati, and everybody, like that, Lord Chaitanya. So when Benjamin Few became a Paramatma body, they had a debate at the University of Texas. We had to put it in the boxing arena. Everybody came, thousands of people. And the biggest theologian in him had it out, and everybody said basically it was a draw, that either one of them could establish it and so on, So he was their superhero, But then he said, I've actually, all this stuff, he said, my basic principle was being honest. And he said, after all this stuff, I honestly have to say that there has to be some force, intelligent force, behind things, causing things to happen. Which is Paramatma. And for them there was... There is no joy in Mudville.
For us is very simple.
Huh?
For us is very simple.
Huh?
For us is very simple.
What is?
For us is very simple because we're taking knowledge.
Because we have Prabhupada's perspective, no? And then we can see, And that's what happens. It's very easy to start, putting all these things in whatever your field is. Whatever it is. If you're a physicist or a chemist or something, you start seeing, then you can publish material that can reach out to people on that kind of level. Yeah. Most people are Shudras, even got a title as a scientist, and you've got to put it in their language and in their culture. And I see more and more, now it's just maybe 35, 38-year-old, very well-situated scientists and stuff are presenting the same arguments Sadhaputta did, but now, they're part of the society, and now it's extending. Britannica says that evolution dominated the idea of archaeology in the 20th century, but now, and even now what's happening is art, because they were making the pyramids with copper things and blocks, You know how long it takes. They even tried to do this. You know how long it. For 3 hours you get a little groove like this. And these are blocks. Blocks as big as this place here, right? And they're carved so flat, they fit together, and you get 1 million of these things. Even a little mistake, So they say, oh no, but that's the theory, And then they show like the place where the rocks came from, gigantic. But the problem is, they have these holes like about this big, right? Where they're carving. and inside they have circular grooves, right? Yeah. Well, they did that too. They had some method of doing that, But now they're applying artificial intelligence with statistical analysis and everything else. Artificial intelligence comes back and says, nope.
It's too complicated.
Can't do that. Yeah. So now they're accepted these guys, and then the other boreholes, right? They were test holes, right? And these things are 5 foot, just about this big, and they go down maybe 30 feet, right? So somebody was inside this place, chipping away 30 feet below the ground in a place like this, right? Yeah, okay. They say even to get the dust out so you don't suffocate, it would be a gigantic problem, But they just ignored it, They got the guys, stupid guys, going away like that, So then the artificial intelligence now is coming back. Well, you also told me the general map of the quarry. The places where these things are specific cleavage points. Oh yeah. They were holes set up to break the cleavage of the rocks, so they could get the biggest pieces out without any flaws in them. Because where all the marble was already had breaks, right? So, but if you break it at the right point, then you can get out these really big pieces and stuff. So we're saying no, where they are was because they were, oh yeah. So now I mean, right on this, they're saying, hey, they had tools that were far superior, to even, we could do it now, but it would be really difficult. I mean, a lot of money and stuff and so on. And they had to make these things and stuff, some kind of motive force, and it was continuous, even power and stuff. It was a lot more than slaves pulling on ropes. yeah. So it's just right, very much at a fundamental basis now. The physicists, and basically all they say is that, hey, we don't know what it was, but look, it existed. Yeah, so there were cultures before us, superior to us. Yeah, not saying there was a God, but yeah, it's changing. Srila Prabhupada ki jai, Mahaprasadam ki jai.